So let us see how we can do influence diagnostics using R. For this purpose, I'll be using this data, which is called life cycle savings data. It's a data from economics. So let's take a quick look at what this is. And I do not think that I know enough of economics to really understand what this data set is all about. So if you want, you can take a quick look at the data and see what it is all about. So there are got various variables. SR, which is aggregate personal savings, and these are two different types of populations, 75, and DPI, real per capita disposable income, whatever that means, and DDPI is the growth rate of that. So briefly speaking, that there are a number of countries. So the countries are the basic units in our data set, and for each country we have a number of variables measured. Out of these, this SR is our response and the remaining things are the predictors. So let's quickly take a look at all the countries that I have. So I will type row names, life cycle savings, and these are the countries that we have. We have got Australia, Austria, Belgium, Bolivia, etc. So all these countries. And these observations are all the average things over a 10-year period. And based on that, we want to check some model which they call is the life cycle savings hypothesis. And for that, they need to fit a linear model with SR as the response and the remaining 4 as the predictor. So let's quickly do that. And let's quickly do that. So we'll have these names. We have the names. Where are these? These are the names. SR POP 15, POP 75. I will carry out the fit. I will fit SR onto all the rest. This dot notation means all the rest. So, and I get a fit. I do a summary. These are my estimated things. These are the standard errors, and some of them are significant, some of them are not. Now, I'm not going to discuss whether this fit is really conforms to that model or not, because I really do not understand the model. I would just draw your attention to this multiple R square and adjusted R square. They are apparently notoriously low, but as our book, the Belsley, Koo and Wells book remarks, this adjusted R square is fine with them. That is, for this kind of study, so that is the typical value that you will attain. So they are not shocked by this value. They are still continuing their study even with adjusted R square, which is apparently as low as this. I had already commented earlier that there is no absolute threshold that you can give for R square or adjusted R square. It is very domain specific. So in this domain, they claim this is good enough. Okay, so now I want to get all those quantities, that is, which of these observations, now let's quickly see how many such observations are there, that is, how many such countries we are considering. We have 50 countries, so we need to know whether out of any of these 50 countries, something is weird. Now, how do I do that? We have learned about various things, DF DF beta S, COV ratio, blah, blah, blah. Now, there is a nice function which is inside R, and that will kind of solve everything for you. And we will show that first. It is called influence measures. You just call influence measures on fit. You do not need to install any package or anything for that. And it will give you a list of all the things that you have described and also draw certain conclusions. So let's do that. And it gives you a huge list. Let's take a look at that. So for each value of I, that is in our case for each country, it will compute the following things. It will compute the df beta s quantity. So dfb, this is for the intercept. This is for pp15, that is one of the regressors. This is for another regressor. This is for this and this. So there are 4 regressors plus the intercept term. These are the df beta s values. Similarly, these are the df fit values. They call it df fit, but actually they are df fit s values. These are the curve ratios, and they also print some other things which did not fit in the table, so they have been delegated to the next line, next punch. So this is called cook.d, which is the abbreviation for Cook's distance. Now we have not talked about Cook's distance, so let's take a quick look of what that is.